So this talk is about sharing my vision for the future of operations as a discipline, at least within modern engineering organizations, and drawing from some of my own experience, my own observations. And I think ops is very much going through a bit of a renaissance right now. I think Andrew's talk from yesterday kind of touched on this. With the move to cloud, the increasing amount of automation, the increasing importance of automation, and infrastructure is just becoming more and more sophisticated. And so I think practices are finally just now starting to grow up around that. And so some people worry about robots taking over the world or taking our jobs. I think the reality is more about how automation will help augment us to build better software and to focus on higher value things. And so it's not so much about the distant future so much as it is about the next 5 to 10 years, what ops looks like in that time frame and why I think it has to retool. So to give you some background on who I am, my name is Tyler Treat. I'm a managing partner at Real Kinetic, which is a consulting group. And I've worked at a few different places of various shapes and sizes. One that some of you might recognize because of the fact that it's local is Workiva. So I was an infrastructure engineering manager there. I worked with a couple different teams, first with their data platform team, and then I moved into their infrastructure and reliability group. And so that encompasses operations, reliability engineering, as well as infrastructure engineering. So I've spent some time on both sides of the coin, so to speak, both the product development side as well as operations and reliability side. And when we think about traditional ops, we probably think about hardware, managing servers, networks and databases, maybe app servers and runtimes. We think about disaster recovery, Nagios checks, and then the business side as well, right, with vendor management and procurement and so on. And then we have applications on top built by development teams. And those might look something more like this, depending on who you ask. But we have this nice separation, right? Developers focus on building products and features, and ops focuses on making sure the lights stay on. But we know the reality is that this separation causes a lot of problems too. So DevOps was sort of born out of this as a way to bring these two groups into alignment by improving communication and improving feedback loops. And now with the move to cloud, a lot of these traditional ops functions are being outsourced to cloud providers. This idea of no ops. And so what that leaves is this thin but important slice between your Google, your Amazon, and those products being built by development teams. This glue, essentially, between cloud and product. And I call this new ops. And I use that very much tongue-in-cheek with reference to like NoSQL and NewSQL. But this encompasses infrastructure automation, deployment automation, config management, logging, monitoring, all of these things. This is operations. It's software. That's where it's moving. And certainly automation is nothing new, and it's a big part of DevOps, I think. I mean, I don't really know what exactly DevOps is, but it's a part of it. And so I want to talk about what I mean by this idea of new ops. But I also don't want to mischaracterize either by showing these nice, clean models of what ops looks like, right? We have our traditional ops, and then DevOps, and no ops, and now new ops. And the truth is, your company doesn't just one day graduate and get its DevOps diploma. It evolves through various manifestations of these different ideas. And so it's an evolution, right? DevOps is very much a journey. It's not the destination. It's not the end game. And so I like to think about this scale of automation from manual provisioning all the way to fully self-service. And we add this second dimension of org size from the smallest startups to the biggest enterprises. And you might ask yourself where you find your company in this two-dimensional space. And we'll kind of walk through this space as we go through this talk. And speaking of scale and size, scaling a business is probably one of the hardest things that a company has to do. And in particular, this problem of silos, because it's a problem that everybody deals with as a company grows. And why is it that they form? And I think many companies start with a DevOps approach, often just out of necessity, because we can't afford to have dedicated developers and dedicated QA, dedicated ops, dedicated security people. We just have people. And those people wear many different hats. And so developers are often pushing their own code to production, managing the infrastructure that code runs on. Probably not a lot of stability, probably a lot of risk, probably not a whole lot of thought towards controlling costs. But as the product scales, we specialize. And as the business scales, we add various safety checks and controls and processes. And so developers write code, ops people run it, QA gets blamed for defects, security blocks everything, and management wonders why nothing gets shipped. And so we end up in this top left-hand quadrant with ops as gatekeepers. And so ops is fighting for stability. Devs are fighting for change. But we more or less have this stable, cost-controlled, risk-averse environment, hopefully. We also have this delivery and innovation bottleneck. And so specialization is good, but misalignment is not good. So the question is, how do we scale specialization? Do we do cross-functional teams? Well, DevOps encourages cooperation. So we just add an ops engineer to each team, and maybe a reliability engineer. Maybe a few extra for on-call backup and so forth. Of course, we need a QA engineer too. Boom, done, right? Problem solved. But hold on, what if we have 40 plus development teams? What if all of those teams are doing microservices? Of course, all of those microservices are special snowflakes, so they all have different stacks, different infrastructure, different databases that they use. And so that quickly gets out of control. But not only that, it's a lot of teams, it's a lot of specialized roles, it's a lot of hiring, it's a lot of headcount, it's a lot of time and money. And so maybe if you're Google, you can just throw money at the problem. This might work out okay, but for the rest of us, it might not be such a realistic option. And so once again, we go back to the drawing board. We ask ourselves, how do we scale specialization? And my thought to how we do this is with vision and product. And I'm going to explain by what I mean by both of these things. So vision is simply a mental image of what the future could be like. It enables independent decision-making and alignment. So it allows all of those teams, the people on those teams, to make decisions without having to constantly coordinate with each other. But as they say, vision without the execution, it's just hallucination. And so products are how we scale that execution. And I want to talk about this idea of operations through the lens of product. But before I do that, I want to take a quick detour. And I don't know if any of you have noticed this or not, but I certainly have, and I've talked to people who have noticed it, which is that a lot of engineering orgs many QA roles have been kind of quietly disappearing. And I think what's happening is this evolution of QA, which is this shift from being test-focused to tools-focused. And we can look at companies like Amazon or Microsoft, who popularized this model of the SDET, software development, engineer, and test. So these companies recognize that by having a separate QA group and dev group, that creates a lot of problems, just like the separate QA group. And so they have software development engineers and tests. They focus on the quality aspects. They have SDEs, software development engineers, who focus on the dev aspects of building software. But rather than having two wholly separate groups, we just have development teams, and we have SDETs embedded on those teams. And more recently, in the past few years, I think Microsoft moved to what they call a combined engineering model. And so they took these two roles and combined them into a single role, effectively, called a software engineer. So software engineers write the product code, they write the test code, they write the tools code. They're responsible for all of that. Because quality is a core concern of building software. And so software engineers write code, they write unit tests, they write integration tests. Tests run in CI, that code moves through a CD pipeline before it finally goes to production. And QA teams are shrinking, but what's growing are the teams building the tools, building the CI environments, building the CD pipelines, building the automated testing frameworks, building the production tools. And the same is becoming true of ops. It's becoming software. And that's what I mean by operations through the lens of product, because the build, release, deploy automation, config management, the infrastructure automation, logging, monitoring, these are all products. And so at Workiva, as we were struggling with this scaling problem, dealing with that challenge, we set a constraint on ourselves, which is we set a maximum of 15% of R&D headcount for infrastructure engineering. We just capped that at 15%. I think constraints tend to make problems easier. And so what that did was it forced us to solve this using technology. And technical problems tend to be easier than people problems. And really what that did was it forced us to productize our infrastructure. And in doing that, we controlled costs. We controlled that headcount. We reduced risk. We accelerated development. And ultimately, we delivered value to customers faster, from about 3 to 4 releases a year to multiple releases per day. And so I think it's high time we start to rethink operations. Because clearly this model of ops as cluster or infrastructure admins, it doesn't scale. Developers will always outdemand their capacity to supply that. And so either your headcount is out of control or your ability to innovate and deliver is hamstrung. And it becomes this interrupt-driven thing where we're just fighting fires. And often ops become the masters of production. And what that usually means is they just become these human issue routers. Because if something goes wrong, we have to figure out, okay, who is the right team or person to actually help solve this problem. They don't have the insight into this particular part of the system. And another common path that many companies take is platform as a service. And Workiva is an example of this. For a very long time, Workiva didn't have an ops team because the ops team was Google. The first product was built on Google App Engine. And this helps a ton to deliver value to customers quickly. But there's also a very real innovation bottleneck with that, right? This idea of ops lock-in. Whether that's a platform as a service like App Engine locking you in, or it's your own ops team who just isn't able to support the kind of innovation that you're trying to do. And so my vision for the future of operations is taking combined engineering to its logical conclusion. Just like with QA, ops capabilities should be embedded within development teams. And I think every role should be working towards automating itself out of a job, which is kind of scary, but I think what it actually does, it allows us to focus on the higher value things. So my vision is enabling developers to self-service through tooling and automation, empowering them to deploy and operate their services. And so you read this and you see, okay, enable developers to self-service through tooling and automation. So here's a CloudFormation template and access to production, have at it. And so the pendulum can swing too far in the other direction, and this was a problem for a short period of time at Workiva as we were moving off of App Engine, building new products off of App Engine. Developers had this newfound freedom, so teams all went different directions. They introduced all sorts of new technologies, new stacks, new infrastructure, new services, and there was this free-for-all and this explosion of stuff, and then the cost explosion that comes with that. And so you have to rein that in a little bit. You have to control that. You can't allow that to happen. So we take our vision statement, we tweak it a little bit, which is we want to enable this stuff and empower with minimal ops intervention. So we still have to have some checks and balances. And so the correct model, I think, is ops as force multipliers. It's building the tools, building the automation to let developers actually own their products end to end, from the code on their laptops all the way to production and beyond, and actually running that in production. And we move away from that interrupt-driven model where we're fighting fires to this new model where we're making the teams responsible for their products, but we're providing them the tools they need to do that. And so I want to unpack this vision statement a little bit, starting with this idea of enablement, enabling developers to self-service through tooling and automation. And that's what I mean by ops as a product team, because the infrastructure automation, the deployment automation, config management, logging, monitoring, these are all products. And those products are what enable teams to actually own their services end to end. And then there's this idea of empowerment. This is also important. I have this theory that pretty much every engineering org, really every company, operates in this fashion that I call pain-driven development, which is as a company grows, it starts to develop limbs. And those limbs are teams or silos. Each of those limbs, each of those teams has its own pain receptors. And so teams operate in a way that minimizes the amount of pain that they feel. It's just human instinct. And so we make these locally optimal decisions to minimize that pain that we feel. And we follow this path of least resistance. And so silos promote pain displacement. And we get this bulkhead effect where product development feels the pain of building software, QA feels the pain of testing it, ops feels the pain of actually running it. And this leads to broken feedback loops. We're just throwing stuff over the wall, right? Developers aren't feeling the pain that ops is feeling as they're trying to run that code. And so this leads to misaligned incentives because each team is just going to optimize for the pain that they feel. It's this empathy problem. How do you expect developers to care about quality if they're not on the hook? how do you expect them to care about operability if they're not on the hook? And so I'm of the opinion that developers won't build truly reliable software until they're actually on call for it, they're directly responsible for it. But responsibility requires empowerment. You can't just separate those two things. So you can't ask someone to care about something and fix it without also giving them the power to do so. And I think most ops teams just haven't done enough to empower and offload that responsibility. And products are what enable ownership. And so we move away from that interrupt-driven model. We're putting teams, making teams accountable for their products. They're on call for it. They're the experts on them. They're best equipped to deal with problems, but we provide them the tools they need to actually diagnose and resolve these problems autonomously. And then lastly, this bit on minimal ops intervention, because we talked about that explosion of stuff. And how do we control that? And products maintain control through enablement. Enabling teams to follow best practices for builds, for testing, for deploys, for support, for compliance. And speaking of compliance, we have to take that and the other SDLC requirements and encode those into our tools, into our processes. These are things that developers won't empathize with or they just won't understand, compliance being a good example of this. And so rather than giving them this big list of stuff they don't understand or care about or empathize with, we take as much of that as we can, we encode that into our products so that if you use these tools, you follow this process, you get all of this stuff for free. We reduce risk that way. And similarly, we can't allow all of those snowflakes to happen. And to do that, we use pain-driven development to our advantage. To do that, we create these paths of least resistance. So we can construct these paths using standard patterns, products, and processes, such that if you follow this path as a developer, your life's going to be a lot easier. You're going to feel a lot less pain. And if you deviate from that path, your life's going to get a lot harder. You're going to feel more pain. And so we end up with this set menu of standardized application shapes, standardized infrastructure, et cetera. And if you want to go off menu, you want to deviate from that path, it's on you, it's on your team to make the case for that. So if I want to introduce closure into our stack, it's my responsibility to present the case for that. And part of that might mean my team will build and support the tools needed to do that. Okay, so I've talked about this idea of operations through the lens of product. And I want to try to provide a bit more detail around that and show what this might actually look like in practice. And using Workiva, again, as kind of a case study of sorts. So this is the high-level flow that I think about from code on laptop to code in production. And starting with the build part of that and the continuous integration. And this is the flow that I envision. It's more or less what Workiva uses. It's what many companies use. Right? So a developer pushes a change to a branch, a code repository, might be GitHub. It triggers a few things to happen. Triggers the build to happen. That's going to run our tests, build our artifacts. That might trigger a QA or compliance process. And then we also have code reviews. And all of these things are providing feedback back to the developer to quickly iterate. And so what this kind of looks like in practice is I push my code up. And Workiva has a lot of automated processes around this. And this is an open source repo, by the way, so I'm not divulging any secrets here. And so you see these automated processes. This first one is a security check. So it's doing static analysis. It's checking for various security vulnerabilities and so on. There's code coverage, if that's something you care about. And then we have our code review process. We tag our reviewers. So Workiva requires at least one other person to review the code for compliance reasons. So the reviewers do their thing. We iterate on that feedback. Once that's been satisfied, they give their +1. And meanwhile, while all of this is happening, we have our builds going on, running our tests, building our artifacts. And then this shows some of the different checks that Workiva has, the tools, the automated processes that they've built. Some are actually off the shelf, some are built in-house. So you can see continuous integration, code coverage, Smithy, which is their internal build system, Rosie, which is the compliance check. So it's going to check for all of your compliance requirements. Do you have your code reviews? Do you have your security reviews, et cetera? And then Aviary, which is that security scan. And so once all of these have passed, our code, our pull request gets marked, merge requirements met, and so we can actually merge that in confidently, knowing that it's met our requirement or compliance requirements for the developer workflow. So there's a few things I want to point out with this. First, the build plan is part of the code. It's not baked into the build tool. There's no external configuration. This allows teams to fully control their builds. You also notice Workiva has very deep integration with GitHub. This allows them to automate a lot of these processes and build controls into the developer workflow. So then we move on to the release stage. That flow looks something like this. I tag a branch for release. That triggers a build, maybe a QA process for that artifact. That artifact goes to a repository. There's also a sign-off process. So Workiva has a lot of compliance requirements. They deal with pre-financial data and so on. So that involves various parties, like release management, QA, security, et cetera. And that might just be clicking a button, depending on what those requirements are. And that promotes the artifact to a production repository before we can finally deploy that out to production. So the artifact build, tagging, promotion is all automated. Container, machine image auditing, so the security and compliance parts of that. Machine image and security patch automation. And then streamlining that sign-off process for various parties involved. So now we move on to deploy. And this is part of that ownership, self-service, and being able to deploy is a part of that. And so we can configure our application. And this is also where that control comes into play. I might be able to configure my application for a gig of RAM, but if I want a terabyte of RAM, maybe I have to get additional sign-off for that. So we can control some of these different aspects. And initially, these deploys might be done by a separate release team who's actually clicking the deploy button. But as you become more confident and your tools become more mature, you can start to push more of this responsibility onto development teams. So self-service deploys, self-service config with those guardrails. And then also the infrastructure provisioning is automated. So we're not creating tickets for some nameless ops person to provision things. There's no ticket-driven development. And I haven't prescribed any particular solutions for these. You might be using Kubernetes, you might be using ECS. It doesn't really matter. What does matter, though, and something that Workiva was deliberate about, was having some layers around some of these implementation details, some abstraction over that. And that allows you to swap out these implementation details. At one point, Workiva moved from using Fleet to manage containers to ECS, and there was virtually no impact. And so having those abstractions helps a ton as you need to switch. Technology, there's so much churn. It's going to happen. And so the self-service deploys is a very huge part of that ownership. And then finally, actually operating our services in production. This is kind of the post-production part. And this is just looking at a cross-section of some of those tools or products. Logging, of course, is a huge part of this and how we debug systems. So Workiva built a structured logging spec, and then they also implemented language libraries which implement that spec. So as a developer, I can just pull in my log library, I get that spec implementation, I can just start logging, I get structured logging for free. Similarly, telemetry, the tracing, health checks, alerting, all of these things. And then you get to more sophisticated workflows and processes, canary deploys and A/B testing, traffic shadowing, kind of these post-production or testing and production type tools. And one thing I want to point out with this, and this is important, you don't need to build all of these things yourself. And you shouldn't build all of them yourself. Many of these products already exist, and it might just be a matter of gluing some of these things together. And it's the glue code that matters. So you don't need to invent all of these things. And the other thing I want to point out is if your takeaway from this is we just need some products and tools that'll fix all of our problems, that's the wrong takeaway. The bigger takeaway is the problems, most problems, are cultural. They're not just technical problems. And so the technology alone isn't going to fix your broken culture. It's not the end game. It's just a means to an end. And the other part is the solutions need to fit the company, its culture, its architecture, its constraints. I know it's tempting to just take something you see off of Hacker News and introduce that into your stack, and the software populism aspect of this, but you have to be careful with that. And so my approach to this is get the workflow correct, even if that's just doing all of these processes manually, and then start to automate more and more of these over time. Don't just dive into the deep end right away. All right, home stretch. So specialization leads to misalignment and broken feedback loops. But it's an important part of scaling a business. So the question is, how do we specialize? We know the traditional ops model doesn't scale. DevOps is about tightening feedback loops and building empathy. New ops is about empowering teams and providing autonomy. So it's not a replacement for DevOps, it's just an evolution of it. It's applying a product mindset to the traditional ops model. So ops teams should be redefining their vision from being masters of production to enablers of production. And just like with QA, ops capabilities need to be embedded within development teams. Again, it's taking combined engineering to its logical conclusion. But the caveat is they need to be enabled. And so that is the future of operations. It's a product team, it's software. And that is where things are moving. And so new ops treats ops like a product team whose product effectively is the infrastructure. And it's creating guardrails, not walls. So it's taking that compliance stuff, the SDLC stuff, it's encoding that into our tools. It's not giving developers a big laundry list of stuff they don't care or understand. And then having them go through this long, drawn-out process and running the gauntlet and having this gatekeeper at the end of this long process. So offloading responsibility helps correct and scale feedback loops. And I think that is how we scale specialization. So traditional ops isn't going away, it's just getting a product manager. Thank you.